is Josh Hammond. I'm an independent crop consultant. I work primarily in the Dickinson and Beach areas, and Victor asked me to do a demonstration with my VERIS Cart. So I think everybody's familiar with our acid soil problems in this part of the state, so I'm not going to dig into that too much. With my VERIS Cart, I'm primarily targeting where I'm going to go take physical soil samples. So I'm going to do a little comparison. So if we think about soil pH and compared it to air temperature, if I told you that the average air temperature in the U.S. in 2024 was 55.5 degrees Fahrenheit, that wouldn't be very useful information, right? It's a real number. It's an average number from everywhere, all mixed together. Similar thing with pH. So if I take 20 soil samples in this little area, mix them all together, send them into the lab, and get one number, it's a real number, but it's not useful. So this VERIS Cart helps me identify where the low pH, high pH areas are within the field. So that's what my VERIS Cart does. We'll touch on a few things. So why the VERIS Cart? What does it do? How does it work? And any other questions you guys might have as we go. So I do approximately half-acre grids when I'm using the VERIS Cart for pH. We have to be less than 1 acre grids to really get good data. If I take soil samples based on my productivity zones, it's not enough information. That doesn't correlate with yield or topography or anything else that I can find. So the VERIS Cart helps identify the zones of high pH, low pH, and then I go and take targeted soil samples and send those into a lab. The other thing, we normally take 6-inch soil samples when we're just taking regular soil samples for phosphorus, surface pH. But when we're looking at soil amendments, we want to target 3-inch depth. So it's a totally different soil sampling process. So this VERIS Cart is measuring at about a 2 to 3 inch depth as it goes across the field. So Jack is in the pickup and he's going to start across the field, and I'll kind of talk about it as we go. So this cart is designed to be pulled by a side-by-side, but I've got this little Colorado and it just seems to handle it a little bit better. So this machine actually measures 3 different things. It measures EC, organic matter, and pH. So as he's driving across the field, it's continually measuring EC and organic matter. It takes 1 data point every second. The pH is only when he stops. You can see the roll cleaners on the front. That just moves the trash out of the way, so when it pushes the probe in the ground, he's actually touching the soil. Every time he stops, it automatically cycles. Might be a little difficult to see, but if you can see where the water was sprayed on the back, that's where 2 probes get pushed down into the soil. So there's 2 probes, each measuring independently the pH, and then I use the average between the 2. And because it's a mobile technology, it's not as accurate as a soils lab, so that's why I use the average. And then I take soil samples, send them into egg vice to correlate back to the field and adjust from there. The question is, how big are the swaths? So I can set up whatever width I want. I generally run on about 100-foot swaths and then stop approximately every 150 feet. So it's less than half-acre grids. And then the end result, after I run across with the VERIS Cart, we'll verify with a soil sample. Then I create variable pH maps across the field. So then we use those to target lime applications. So there'll be parts of the field that get 0 lime, parts of the field that get 2 tons, some that gets 5 tons. So that's kind of the main point of why we do the VERIS Cart.
Yeah, this is from the field here at the station. VERIS, when was that, Chris? About April this year? And you can see the different colors, they represent the different soil pHs. We have pH over there as low as 4.2, and that area has been lined about 6 to 7 years ago. So that's another answer that through applied research we want you provide is when do we need to go back and apply lime again.
So the question was, what was the pH range on that field that they measured? 4.2 to 6.2 in that small field. And then as I get out to beach, we've got the opposite problem. We've got really high pH. So I've got fields that have areas over 8.4 pH. So then we run into issues with chemical carryover and things like that. So as I go to beach, what I use the VERIS Cart for is writing variable rate residual chemical maps. So we don't injure peas and sunflowers and those kind of things. Question was, are we trying to amend high pH? And I have never found a thing where we can do that. It's easy to amend low pH, but nothing we can do about high pH. Lowest pH I found, 3.9 is what registered in the VERIS Cart. All right, thank you.